Good evening, ladies and gentlemen. Welcome to the Saturday evening session of the Extraordinary Technology Conference 2013. It is my pleasure tonight to introduce you to Rolland Gregg, and he is going to be speaking on the next incarnation of the Rolland coil, which he calls the Vortex Resonance Coil. I've been watching the evolution of this in the back room and seeing some of the experiments, and this is very exciting because to me, the Rolland coil represents the next quantum leap for our energy technologies. So without further ado, here is Rolland Gregg.
Hi there. Thanks for coming. I've had the chance to meet a good portion of you, and I appreciate your interest in this. It's a passion of mine. Just a little bit background on myself. I actually wasn't expecting really to come here and present on this. I was expecting Daniel to come, and I may have been here to support him. But as it turns out, I'm here, and so I'm going to do my best to relay to you some of the progress over the last few years of what we've been up to. My own personal story here is I actually have a background in corporate marketing, and so that's my professional background. And over the last 5-6 years, I've taken a real passion on finding solutions to our basic fundamental issues on the planet, and that's water, food, energy, healing, and shelter. And so that's where I've focused my energy the last 5 years, in traveling the planet, meeting with different inventors who have different solutions, seeing if those solutions hold any water, or if we can replicate their performance characteristics, and giving them my support, whether it's money, love, my network of friends, or my professional advice on how we can move and help them forward. So that's kind of been my own personal path here. And I met Daniel here's kind of nativecleanenergy.com. This was formed about 5 years ago to empower communities with affordable and sustainable energy, water, food, healing, and shelter. And so NCE seeks out the most technologically advanced renewable energy solutions that develop an effective synergistic relationship between our communities and our planet. What I've noticed is all these technologies that seem to actually work really well, they actually mimic some of the natural processes in nature. And a lot of that process that we're going to be talking about today is the vortex. The vortex seems to be the path of least resistance. It seems that everything follows this pattern: air, water that flows in this pattern naturally, molecules, atoms, electromagnetism, everything spins in a vortexing fashion. So let's move along here. So this is a little graphic that kind of displays what our intentions are with the vortex coil. And so we really want to make the vortex technologies available and affordable globally. When I say vortex technologies, there are many different applications for the coil that you see sitting here in the front here. We've already currently are in the process of open source distribution of detailed knowledge to allow for faster development and collaboration. You can buy this coil right now at onestopenergies.com, and you can get the same results that I'll show here in a little bit. We provide support to people working in the fields that give a basis to the understanding presented in the working technologies. We want to research potential health benefits associated with the particular post-electromagnetic field therapy frequencies. Earlier this conference, there was a gal who spoke in depth about the different post-electromagnetic field therapies and how they have positive benefits in entrating the body into a healing state. And so this has a very large field that emits, and you can control the frequency input, and you can also do that as well. We're going to license applications to companies with the ability to implement into working devices. Particularly lighting is an area that this coil is very useful for right now without too much further R&D. We've been able to do a lot of interesting things. You'll see some videos of what we've done here in a moment. I'm going to open a facility that would allow for quick and easy adaptations to newer designs as new ideas are generated. We want to create animated simulations of the flowing energy to develop new understandings of the mathematical relationships of that coil. The basis of this coil was inspired by the vortex-based mathematics, which is brought about by Marco Rodin, and it's been evolved by Randy Powell and others who are here. And there's been a lot of people who've input into evolving that, a large team of people that I couldn't mention all their names right now, but we're thankful for them to continue to be working on this. This coil was built by Daniel Nunez and his wife Erica Nunez. They were inspired by the work of Marco Rodin and Randy Powell, Victor Schauberger, and other people that they've studied to see the natural flow of how the vortex works. And so they did many iterations of this. They tried and tried over the last 5 years, and they came to a particular shape that, in a particular winding pattern, a particular way of inputting and outputting the energy, where it actually rang like a bell at certain harmonic frequencies, and a lot of energy was pumped out. So that's just a little caveat there. The last one here is we want to create an understanding that vortex technology should be preferred over older, more wasteful technologies. There's many ways to harness this power, and with further R&D and help from electrical engineers, we can utilize this in all of our electrical systems. So that's just a little bit about our intention and our mission. So first video we're going to watch is a really interesting video. It's the first time that I met Daniel Nunez. This was last summer. And so I'm just going to go ahead and, well, I'll describe what you're going to see on the video here. It was basically, bless my wife's heart, I have a large network of friends who are interested in a lot of the same things why you guys are here. The alternative energy field, the health field. And whenever I get a call from a friend like, hey, you got to come see this. There's this coil, or there's this car running on this, and they're doing this with emissions, or whatever it is, I'll get in a plane and I'll fly there, or I'll get in my car and I'll drive there. No matter how far away it is, if it's in Mexico, if it's on the other side of the world, I'll fly there. I'll go and I'll figure it out because I'm so interested in this. And I want to see if there are solutions. I want to help get those to the next step. And so a friend of mine called me. He was in Northern California, and Daniel and his wife were staying there. And we basically got a call from them saying that I'm going to actually shut off this right now. I left this on. We got a call from my friend in Northern California, and he said, you got to check out this coil. There's some anomalous things happening. So I get in the car, drive down with my partner, Declan, who's also a partner in Native Clean Energy. And we'll just take a look at the video. So this is the vortex coil on the left-hand side. Here, I'll grab this. This is the unification coil. So the unification coil is the coil that you see here. A Rodin coil wrapped
You
over
touch
it.
it with that one and then hold my hand.
Declan is on the left.
So you touch.
Daniel's on the right. And this is kind of a spur-of-the-moment thing where Daniel's like, hey, check out this power that comes out of the coil. It's harmless. Trust me. He says, put your finger on the end. No, trust me. And so my partner was like, what are you making me do? Anyways, he puts his finger on the end, touches Daniel's hand. Daniel touches the lights in the bottom. I'm not sure if you can see the bottom. Okay, there you go. And he's lighting up the actual, those are neon lights. They take 60 volts to light up, and he's lighting up 2 of them. So the energy coming out of the coil is going into Declan, through his hand, through Daniel, and into the neon lights. And that's a human circuit. And that was blowing my mind when I saw that. And so we played around with the output of it, and it seemed like it's safe. And so that was the first time I met Daniel, and he was showing me all these anomalies with the coil, some unique things with the lighting, how big the frequency of the field was, and it was really amazing to see this. And when you first meet Daniel Nunez, if any of you guys have watched his videos, you realize he's sincere. He means well. He's not a charlatan. He's not trying to take anybody's money. He's not trying to show something and be some Hollywood star. He's just sincerely doing what he feels is going to help the planet. So that's kind of the first time I met Daniel. So. Yeah. We can go back to the slides. Thank you. So I'll explain how it's wired up. This is a little diagram. On the left-hand side, it shows a closed circuit. On the right-hand side, it shows a load. So when this is actually closed, when you have So how it works is we have a signal generator that puts an input frequency into an amplifier, which then outputs into the coil. And then if you close the output channel to itself, it becomes a pulsed electromagnetic field therapy device. And you can actually create a very large field at whatever hertz frequency you like. And we've noticed that from 1 to 25 are pretty beneficial for healing and for resting and really helping you sleep. And so that's on the left-hand side, you can see that. There's the frequency generator, the amplifier, the A and the B, which is the coil, how it's wound, and then the closed circuit. And one of the interesting things about the coil, as you'll see right here, is there's an A leg, and there's an A channel and a B channel. And the input actually goes from a leg of the A and a leg of the B. So this is not a traditional transformer where you have a primary and a secondary winding. This is taking one leg of A and one leg of B, and it actually goes through and comes out one leg of A and one leg of B. It's kind of like if you can imagine, an extension cord that's crossed. And so it's very unique in the way it actually is wound and the way it's actually wired up. On the right-hand side, it's the same configuration, except you can see a load there at the bottom. And that's just fluorescent lights. This right here is a DC hookup to where we have a 12-volt battery right here. And then we have a transistor and a little circuit there, which goes into the channel 1 and channel 2. And actually, that's a pot, actually. And it comes out here into the transistor and the resistor, and that goes to a bank of LEDs. And so that's the 12-volt hookup there. So we'll be watching videos of both here shortly, so you can see actually that. And we'll actually, I think, after this, we'll watch the video on how to build the Vortex coil. This is the Vortex coil disclosure video. If you want to roll that. Video 2. So this is the ABHA coil step-by-step instructional. This is the vortex-based mathematics toroidal
Did you
shape.
want the audio on that?
Yeah, sure. It's just a piano, that's fine. It's nice. This is the shapes of the torus and the fields that are emitted. This is the same shape that your body creates. Your body actually creates a field that comes in their head and out the bottom, a big donut. You can measure this field with dowsing rods. This is the frames that we've built. That's one of the first ones that we've actually used a jigsaw to cut. We've now got a 3D printer that we're printing off the frames. This is the different sequences of the vortex-based mathematics. So these are the necessary materials. You wind channel B counterclockwise starting at one end of the points, and you basically just keep winding it. When you wind it, it's really simple. You just pick one over, and you follow that pattern all the way through. When you get to the end, depending on how many wires you can use 6 wires, 12 wires, 10 wires, 24 wires. It's the shape that matters. When you get to the end, you actually solder. Say you use 12 wires. You'd have 6 wires and 6 wires, or 12 wires and 12 wires. You'd take actually 6 of the wires, you'd make it into 2 channels. So you actually solder the ends of those wires together to just have 2 wires, 2 continuous wires. And then there's a beginning of channel A and the end of channel A and a beginning of channel B and end of channel B. And so that's where it's showing taking the enamel off with the Dremel. So then you would tin the ends. So that's the unique thing, is the energy is actually going down and past each other at the same time. So it's going down and back, down and back, down and back, creating this resonant field. So you can watch this video at home if you have the electrical skills. You can build this yourself. You can buy the frames from us. You can even buy a full coil from us. But it is really fun to actually wind it yourself to understand exactly the flow of the electricity and what's going on. And that's the finished coil. It's enameled magnetic wire. That's, I believe, 24 gauge. This is the same wire that you use to wind motors, generators, alternators. Thank you. So this is the picture of the actual field. And what the anomaly is, the main anomaly which we'll show here shortly after these two slides, is that we seem to be able to put in energy and get more out. That's what we're witnessing. We're witnessing that. How? The use of voltmeters, amp meters, oscilloscopes, loads. We've witnessed that we put a certain in and we get more out. Now, it was hard for me to believe until I actually did it in my own shop and lit up my own lights and had my own oscope and my own meters and my own amp meters and did it over and over again, unhooked everything, hooked it up again, used different meters, and it all said the same thing. So the anomaly is that normal transformers, if you're going to take 10 volts up to 100 volts, you would lose amperage. In a normal transformer, you'll pick your volts up and you'll lose some amps. It's just the law of conservation. What seems to happen here is that we don't lose the amps. So say we put an amp in at 20 volts, we're going to get a few hundred volts out and an amp out. And this is like, depending on what size of the coil, we make 50 to 70 feet of copper wire, which then is soldered together. Depending on how many solders we have, it'll turn up to hundreds of feet for each channel. There should be some loss there in our amperage, just in that fact alone, that there's a ton of wire. Normally, if I've friends of mine who throw a lot of big concerts, there's a lot of amperage when they have these generators that goes out. There's amp loss with the longer line you have. It's impedance in the wire. But we don't get that with this. We don't see it. We don't see any amperage loss. But we do see a massive voltage spike into usable energy. And so people ask, well, how does it do that? I don't know how it does it. I'll be the first to tell you, I have no idea. I mean, I've got some ideas. I've got some theories. We believe that this shape is the path of least resistance, that maybe there's some shearing and spiring going on with these fields that are clashing with each other, and maybe they're somehow like a rubber band bouncing off each other and accelerating itself and picking up more voltage and more electrostatic energy available all around us. This is TeslaTech, so Tesla, he was able to do some things that were quite anomalous. We think that there's some anomalies here. And we're the first to ask others. We want third-party validation. We want labs to take a look at this and take and put their really expensive equipment on it and tell us what they see. We're completely open to that. So this is just the shape that goes in. The toroid comes in and the vortex goes out. We've made them big, we've made them small, and even the small ones have the same effect, granted on a smaller level. We've made them from 24 to 14 gauge, which is what this one is. Obviously, the higher the gauge, the more amps we can put through it without the wires burning up, and we can run larger loads. So now these are some of the coils that are for sale. So we'll go ahead and show the video of 3 different types of meters and the oscope and the lights. Video 3. This is a video my partner Daniel made. He has fun with some of the animations. That's onestopenergies.com. That's where you can go buy the coils right now today. This is the PoE Mini over unity measurement using 6 meters and 1 scope.
Hello everyone, this is Daniel Nunez with onestopenergies.com. Today I'm going to do a little PoE mini demonstration of over unity, just to show people that it's not the size that matters. We could still achieve over unity with this small coil, and let's show you what I'm looking at and why I think that it's over unity. So we've got the small coil. For those of you who don't know, there's a sound frequency that comes out of this signal generator, and this signal generator could be replaced with an Android phone. So anyway, this is a sound frequency that's generated with this machine. It's being amplified by the Insignia amplifier. It's a regular home stereo amp. That goes into the coil. We're measuring amperage, voltage, and the power with an analog meter. Then it comes out of the coil and into the LED panel where we're also measuring amperage, voltage, and power with another analog meter. We've just got this pickup coil kind of right there just to show the distance of wireless electrical connection there. So let's go ahead and turn it on. Start up the sound frequency. We're using a frequency of 17.1 kilohertz. So from the speaker, we're generating a voltage of 21.7 from the output speaker plugs on the amplifier. That's what's feeding into the coil. We're looking at 0.074 milliamps. All right, and look at our power is over here. Just take note, we're looking at it on a 250 volt scale there. So we've got some wireless activity going on with our pickup coil. See, this is wireless energy. We put it on top, it's a lot brighter. But I just wanted to see at a distance how many inches we could get. We're looking at about 2 inches, 2.5 inches. So on the output side, we're looking at 0.024. So the amperage is lower. Now that could be changed with a capacitor by putting a capacitor across the outputs, but I wanted to do this without a capacitor, so this is just the coil and the raw connected to these LEDs. Our voltage is 113.8 volts. And check out the power, same measurement, but now we're up in the middle. So that's a big difference there. So overall, what we're looking at is over here, we're looking at 1.6 watts on the input, 2.7 watts on the output. So not a big difference there, but it is a difference nonetheless. That's the scope. That's what it looks like. So output is yellow, input is blue. So you could clearly see that there's the same number of waveforms per each pulse, and the output is greater than the input. So what does this mean? Well, it means that this type of coil could potentially be wired up in a very specific configuration to make it power itself. And that's the ultimate goal here. We want to have these coils self-powering. We want to somehow recapture the extra energy that's coming out of the output end and loop it back around. So that may mean storing a bank of capacitors. So, we have a bunch of different types of capacitors here, and we've been experimenting with that. But nonetheless, it's an interesting concept that needs a bit more analysis. Not to mention, if I go ahead and I disconnect those LEDs and I just leave this coil open-ended pulsing, it will start creating a large amount of ozone, and it sprays out directly from the center of the coil. So I'm not too sure why that happens. It's just like this arcing that happens with the intense magnetic field right in the center of the coil. So nonetheless, I mean, in practical terms, this means that we could essentially create technologies that are far more efficient. And regardless if they power themselves or not, it's always amazing when you have something like this just demonstrating that you can clearly get more power on the output side than the input side. So that's where we're at today. It's the same thing that we've been demonstrating for quite some time now, but we're basically looking to implement these things in whatever avenues that we can implement them in, whether it's pulse therapy, high voltage lighting, or what have you. So just wanted to touch in, let you all know that over Unity is possible with the PoE Mini, and let you know that they're available on the website. That's shop.onestop.energies.com. And please feel free to post this, share it with your friends. Let people know that energy efficient technologies are here today, and they just need a bit more attention. So thank you all for watching. Thank you for sharing, and Love and blessings to you all.
That's what I thought when I first met him. I was like, what? Are you kidding me? Get me one. I want to test it out. So yeah, that's Daniel Nunez, and I wish he could be here today, but he's here in spirit, and he's a large inspiration to me. The next few slides have an interesting, I'm a horticulturist at heart. I love working with the dirt, working with plants. I love seeing the interaction of the different microbes and the funguses and the light and how photosynthesis happens and how a plant can do something and make, all this energy from light and water, and it's the ultimate transmuter. And so I grew up in Alaska in a place where it was the landscape was beautiful. It was just gorgeous, and I grew up in the woods basically. So I really appreciate plants, and so when I can figure out ways to help work with them more, it was just amazing that this coil actually helps plants grow quicker. And we're going to show some pictures of a particular experiment of that. So this was a blue and red light that had 660 and 440 nanometers. And the coil is actually powering the light on the right-hand side. You can probably barely see it right there. And it's working at its resonant frequency to power the light at its super, less than a watt of consumption. And you'll see on the left and the right trays, there is a wheatgrass growing in there. And so this is day 1, this is day 3, and that's on the right-hand side tray, it's actually germinated and started popping through before the left-hand tray. It's day 5. You can see the difference in the growth from the left to the right. And this is day 6. Again, you can see quite a bit difference in the height of the wheatgrass. And then day 7, just a lot more mass in here than here. And they were planted and watered just exactly the same. And so this has been done over and over many times. And we've had trays all around the coil, and you can see the radius of the effect on the biomass. So there's definitely something is happening with the field that comes off of that somehow interacts with the growing of the plant. Now, I don't scientifically know what's actually happening. I'd love to see with more scientific rigor what actually is changing in the actual plant, why it's growing so much quicker, why there's more biomass. I can take a stab at it. Maybe it's because some of the frequencies that is emitting are similar to what the sun emits. Maybe that's the case. Maybe there are some beneficial things in there that help photosynthesis happen, so it's actually able to convert more of that light and the water into actual mass. So that's what I'm guessing at. So this is another actual configuration of the coils, if you will. The coil in the middle is being powered, and the coil on the top and the coil on the bottom are pickup coils. So there's quite a bit of induction that comes off of this, and I'll show you this and I'll demonstrate it here after I get through some of these slides. But if you put that amp meter right in the middle, you'll see upwards of 60 amps being measured right in the center of that vortex. So there's a big magnetic field that comes out of the top and the bottom, and you can actually recollect that energy and use that to power more loads. And we'll actually show that on this next video. So it's a side-by-side lighting comparison. Again, this is Daniel. So we've been helping him with funding some of the experiments he's been done over the last year, Native Clean Energy has. And then we've replicated some of those over here in Seattle. Daniel's in New York, in the Bronx. So this is a 12-volt setup. He's saying it's all about the geometry, which unites all things.
All right, so this is...
So you can hear him speak a little bit about it.
LED Christmas light bulb. plugged into the wall. And as you can see, the bulb normally consumes 3 watts of power.
So it says 3 watts, it's a kilowatt meter. This is a regular Christmas
You
bulb.
can get a feel for the intensity there.
He's showing a before and after, so right now it's just plugged straight into the wall.
And now we're going to plug it in to our system. So now we've gone and plugged it into our system. Get a feel for the light.
So then he plugs a different one in, straight into the coil.
And the current wattage that we're running is somewhere around 2.5 watts.
So it's, instead of 3
So
watts,
we're
it's
running
about
a
2.5
45 volt
watts
setup,
for plugging a
Those are
Christmas ball
batteries
directly
there.
into the coil.
and we're using 53 milliamps. So now we're going to have some fun with this very new technology. So we're going to go ahead and plug in one more light in parallel. So now we have 2 lights. We'll come back over here. So there's one of those lights to help us out. And you see that the amperage went down. So we're lighting 2 lights and using less energy.
How do you explain that one? I don't know.
But the
it's
plot
what's
thickens.
happening.
Because we have this unification coil sitting on top of the ABHA coil that's creating the oscillation. So what I've done here is I'm taking the output energy from this coil, passing it through a rectifier, and plugging it into that panel of lights.
Third
there.
light.
So those are ultra bright LEDs, putting out somewhere around 220 foot candles of light, where these little Christmas bulbs only put out somewhere around 27. Now go ahead and look at that. It's still using the same energy. It's still using the same energy to light another panel of LEDs from the induced energy just off of the top. So we can go ahead and put another coil on the bottom and extract even more energy and use nothing more, actually bringing down the consumption as we increase how much current we're using. So it's pretty interesting stuff. This is the beginning of revolutionary lighting. So just wanted to share that with you all. Thank you for watching. If you have any comments, questions, or feedback, feel free to post in the comments section below. As always, thank you for your support and blessings.
So the interesting thing about this, a few anomalies there, of course. One, you plug it into the wall regularly, it's 3 watts. Plug it through the coil, it's 2.5 watts. Okay, that's cool. We've noticed that quite often if you just plug things directly into the coil, there's an energy reduction for the same performance. It needs more testing to really validate and verify that, but that's what we've noticed. But then, of course, he plugs in another light, and there's a reduction in the amps drawn, there's a reduction in the power, but he's got more light, and then he plugs, and then so that's all with just the one coil. And then he takes another vortex coil, puts it on top, takes that to a third light, an LED panel, and lights that up, and there's no increase in the input of power, yet we're still lighting up more lights. So, like you said, you could put another coil on the bottom because there's a field there that could be utilized as well. So there's many anomalies with these that we've not fully fleshed out. There's a lot more to be done to understand how to fully utilize these coils. These are just some of our observations. And this is the vortex coil and Lenz's law. One of the interesting experiments Daniel's done is he's actually taken, I'll explain that this is actually with one of those meters that you can buy that senses the north and south poles of a magnet. If this was a magnet, you'd put it here, and say if this was the south pole, it would show the light would light up where the S is, and if this was the north, it would light up N right here. Well, what he's been able to do is show that no matter where you put this meter, on the outside of the coil anywhere, it's always showing the south pole. So that could mean that the north pole is maybe somehow inverted in the inside or something, but as far as the field that's being emitted, there's only a south pole noticed on this. So essentially it has a monopole characteristic, which is also a unique thing. And so with that, you can spin the magnets quite easily. And you spin magnets, you can spin a rotor, right? You spin a rotor, you can do work, like real work. So there's a video here that's a little bit longer. It's 22 minutes long. I don't want to show it here, but you can see it on his YouTube channel. What happens is it starts off with the frequency very low and goes up to, I believe, 20 or 30 kilohertz, which shows the total power consumption actually at 200. It starts off around 210 watts when you start off at the lower frequency. And then as the RPMs go up and up and up and up, as the frequency goes up, he ends up around 95 watts total power consumption. So oddly enough, and he does show that he takes a screwdriver and like presses down hard on it's not a torque meter, we know that. We'd love to have a torque meter. They cost a few $1,000s. But he shows that there's quite a bit of torque on that. And so what's Lenz's law? Lenz's law, for every action, there's an equal and opposite reaction. It's a reverse armature. So Lenz's law is basically if you have an electric car, all electric cars, they don't have traditional calipers that squeeze brakes. They actually have they put a load on the motor, which charges the batteries up, and that actually puts a negative torque on the actual the motor, and it slows you down, and that recharges your batteries. That's taking advantage of Lenz's law to charge your batteries up in an electric car. So basically, this is negating Lenz's law a little bit, or playing with it to where normally you would have to increase your power to increase the RPMs and increase your torque, but that's not taking place with this. So that's another anomaly that needs further explanation, further exploration. And we'll just take a look at the south monopole, which is, I believe, video number 5. Yeah. So again, this is Daniel. He makes some great videos. So we showed it with AC to produce a south pole, and this is with DC to produce a monopole. So there's a 12-volt battery right here. He's got a little coil there. Or he's showing a solenoid. This is a regular solenoid. This is a traditional solenoid transformer. He's showing the north and south poles. That's what he's showing right now. He's like, okay, see, north, south pole, great, normal. And then he hooks up the vortex coil. Unhooks the solenoid, the traditional coil. And I don't know if you can see the light on his little electric thing too well. Oh, there you go. So south. And no pole. South again. So he's just switching the poles now. And of course, it's going to switch the actual side that the south pole registers on at that point. So that's one of the anomalies. It's one of the things that helps spin the magnets. You can actually, we've done this, when you have a magnet in your hand, it'll be spinning. If you put your hand next to the coil, it'll spin one way. Get to the equator, and it'll spin another way. So he's just showing a regular magnet with north and south poles there. south again. Nothing. So that's just one of the anomalies. He even shoves it in there to see if there's anything in there, and he still can't register anything. So, other than the one south pole. So that's the monopole anomaly. Then I think we're going to now show the video 6 and explain what's going on here, which is the, it's quite interesting, this one. It shows both the double recollection of both magnetic fields, both poles. He's actually talking to another co-researcher, Charles Fraser, who's been working with us.
Oh my gosh.
We've got 576 LEDs, and we're only using 1 watt.
Oh my god.
That's Charles.
Yeah, and the
Daniel's
plot
talking.
thickens.
So they're only using 1
How
watt
much
to light
thicker
up
can it get?
that whole panel,
Yeah.
and
So I
2
did
panels
the
over
math-
here. He'll
I did
show.
the math on these two. So to light up this number of LEDs, you normally use 28 watts, and we're using 1. And the battery would normally last 58 hours. Excuse me, it would normally last 1.5, and it's lasting 58 hours with this system.
What?
So yeah,
58 hours. So we increased the runtime by putting on more LEDs.
So a lot of this doesn't make sense, right? You increase the runtime, putting in more LEDs. Why doesn't make sense in our traditional world? But that's what we're observing.
Yeah, man.
Normally,
So all you need is a big capacitor, and then in theory you can charge another battery in less than 58 hours.
Exactly. Yeah.
Really?
so
How long does it take to charge one of
that's
those
hopefully one
batteries?
of our next experiments is using capacitors to do that, recharge the battery in less than 58 hours, and we don't have to
Can
worry
you show
about,
us all the lights
you
that
know,
you've got in series?
charging that battery up again.
That's 576.
So
Can you show us in the camera?
he'll move the camera to the left to show the lights here in a second. All the lights.
Oh wait, no, those are the lights on the left. Okay.
Yeah, I'm not seeing my camera.
Okay, well no, I see some lights on the left and some lights on the right. So look, he's lighting all of these lights with 1 watt of power. Oh,
Charles is a funny guy.
oh my god.
So yeah, so that's 1 watt of power.
Oh my
Normally it
God.
takes 28 watts. Normally it would drain the battery
Oh
in
my
an
God.
hour and a half, but we light all of them up for 58 hours and then the battery drains. So
We took these 2 coils there, and these coils
that's the recollection of the energy fields at the top and the bottom. Now, again, you can still spin magnets on the sides
Okay.
here. You can still spin magnets on the top and the bottom. There's still
Oh
a
my
field
God,
there that
man.
will spin magnets.
That's really powerful.
If you have a rotor on that magnets and you've got some pickup coils with some magnets on the end of that rotor, you can make more energy. So we haven't done that yet, but that's one of our future plans to do, to test that out.
You wouldn't even notice the electrocuted you, would you?
I think we're good with this one. So this is a recent, very, very recent development, as in this week. I've been following this work for some time now. I've actually been playing with crystal batteries myself. I've had a crystal battery that, I'm not sure if you guys are aware of the crystal battery phenomena. I don't think anybody's really spoke too much about that yet this conference, but I've actually experimented with the crystal battery. I bought a kit from Rick Friedrich, who sells and has worked with John Bedini. And what's interesting about this kit I bought like a year and a half ago, and it basically takes a copper bowl a little plastic spacer, and then a magnesium plug, and some alum powder that you sprinkle in between there. And then you spray it with some distilled water. There's an anode and a cathode to the copper and the magnesium that goes up to an LED light, and that lights it up. It's about 4 days, and the evaporation of the water, the light goes out. You spray it with some more distilled water, the light comes back on. And so we use that for a night light. There's a little switch on it, my wife and I, for the last year. And it's a great little light. And the only thing is you got to add more water, right? So that was very interesting to me. So I followed the crystal battery cells to see what other developments. And there's a guy by the name of Marcus Reed in Germany who's been working on this since 1999, and he's had these little cells in the front. Each one creates about 1.5 volts endlessly. And these are sealed, so you don't have to add water. They actually just continuously pump out 1.5 volts. And he's got all the data that shows them recharging themselves, discharge, recharge themselves over many, many years. Since 1999, he's got one that's been running and powering LEDs. So of course, you can put these in series and get more voltage, or in parallel, get more amps, What our goal is, we've got him a vortex coil. We would like to get, 6 of these, enough to produce over 12, 14, 16 volts, and amplify that up so we can actually use this to amplify these in lights currently, right now, where you never ever have to turn a switch on, and you don't have to use any solar, any renewable energy. It just is recharging itself through the ambient energy all around us. And so that's one of the next evolutions of what we're working on with this, and these crystal batteries. And so we'll actually probably be selling these as well, and they're for sale right now through Charles and Marcus Reed, the gentleman who you saw previously in the video. And if you want any more information about that, of course, you can contact me at that email, give me a call, stop by either Daniel's or my site. And we welcome collaborators, and they're looking for financial and distribution partners to help bring some of these vortex coil applications to the market. So with that, I'll take any questions you guys have. Yeah.
Justin, why don't you come on up here, and anybody wants to ask a question, stand up and answer questions. Sir.
So it seems to me all this experimentation that you've shown, it's very, very interesting science, has been being done in the northern hemisphere. And I was wondering if you have anybody that has tried to replicate this in the southern hemisphere.
Have we? I think we have. I think we have someone in South America. Don't remember exactly where, but I know there's somebody in South America who has replicated it, yes.
Well, I'd like to see actual video of that, because I got an idea whenever you were just a moment ago about where the energy might be coming from for your coil, and a possible danger actually that might be with the coil.
Okay.
I think that the reason it only produces a South Pole is because we're in the northern hemisphere. If you were to build one of these things in the southern hemisphere, it might make only a North Pole.
Interesting. Okay.
And I think what's going on actually is where the extra energy that you're getting, it's coming from the magnetic field of the Earth. When you produce only a single pole in the North Pole and it's a South Pole, you're actually sapping the strength of the North Pole from the Earth.
That could be a very good hypothesis, and I'll have to check with Daniel on who we have in the South Pole.
Right, and if we were to try to power our civilization off of this type of coil, it would actually sap all the energy out of the magnetic field of the Earth, and it would take away the Earth's magnetic field, and it could be very disastrous if you were to power an entire civilization off one of these coils.
Interesting. It's one hypothesis.
Actually, water and electricity have a lot in common. Water pressure and voltage are the same, and current and flow are identical. Just remember, when it comes to a magnetic field or electronic field, you can't just sit here and pour water into just onto the floor and have it disappear. Water doesn't come from anywhere. It's the same with energy and the same with the magnetic field. Anytime you have a flux flow, it has to come from, it has to go to somewhere. So somewhere it's hiding. And we've got a couple of magnets back there that look like monopoles. In fact, it's south all the way around. But if you partition them off, the north is actually hiding down inside. It's an interesting magnetic field. We thought we had a monopole, but we started slicing it off. Electricity doesn't appear from anywhere, and flux doesn't appear from anywhere, just out of nowhere. And that's also telling you clues how to solve the step to jump to the next level.
Thank you, Don.
Part of that level. I did have a question now. Did you try reversing the polarity to see if the field would change north to south?
Yeah, we did that. We did that.
Yeah, okay,
Yep.
I missed that. But the next question I had was, when you were doing your biofield experiments, I was noticing, were you using AC or DC power? You know, what kind of voltage and amps? Was it settle? Was it, you know, how were you powering the coil to get the results?
I believe that was AC that he was using then.
You were using AC
Yep.
during that period of time? And then
And I don't remember the amps and the volts on that.
pretty much answers my question.
Okay,
Thank you very much.
From Porter, Texas.
So I'm over by you.
Oh, off FM 1314.
Yes, sir.
Lucian, sir.
Hi there.
Hi, I'm Lucian Ionescu, and very nice presentation and amazing phenomena going on. And I think I have some ideas going to foundations of physics, because I studied a little bit rod in coil,
Okay.
like in a year or two,
Okay.
and I came with a similar idea of a twisted wire, but I didn't get to the final
Yeah.
technological level. But the main point is what has to be investigated is the so-called vector potential of the electromagnetic field, not the magnetic field, or in plain terms, etheric flow.
Uh-huh.
So you will find some interesting ideas in my talk at this TeslaTech on quantum information, biofields, and etheric energy, where I also explained that there is a thing called a magnetic charge and magnetic current, but which is due to this vector potential, which physicists say is just a mathematical gadget, does not exist.
Right.
So more information.
Thank you.
If we talk
Yeah,
later.
I'd love to talk with you. Yeah. Yeah, I'd love to
Thank
talk to you
you.
further. Thank you. Appreciate your input.
Thank you, Lucian. Yes, sir.
Thank you.
Hi there.
Question about scalability. To
Scalability.
get
Yeah.
more power, what do you need to do to increase the frequency, to increase the size, to
More
any
power. So we've basically have built bigger gauge to handle more amperage to handle bigger loads. So if we were to put a larger gauge, even go further down to 12 or 8 gauge or further, we would be able to have even more amps, and so we'd have bigger loads. And you know, we've only put 20 to 40 volts in. We've gotten 1,000 volts out or so. But if we put 100 volts in, we may get a few thousand volts out and not lose any amps. So we've just tickled it. We haven't really tested it. We've not really burnt out a coil. We've not seen the other end of it. So there's a lot more testing to see how big we can go and how much will come out. We've only put a little bit of voltage in. So.
And the frequency you're using is what, 17 kilohertz, you say, right?
For that particular demonstration, it's actually dependent on the load, the size of the gauge of the wire, the shape, the hands that built it, because each one's being built by hand right now, so there could be some different anomalies, and also the amp that is. So it's specific to each particular demonstration. Certain coils will have a certain area. We found that the larger the gauge, the coil, the lower the frequency which it resonates. The higher.
And what happened if, say, you were doubling the frequency with maybe a smaller size to have the resonance at a double frequency? Will it double the power or quadruple, or is it linear, non-linear? Any idea?
We just need to do more testing. We don't know. If someday we'll be able to have the equipment to test voltage, amperage in, and all the frequencies and all the combinations thereof, and then we'll be able to plot that curve and see that. So, yeah.
Remember, when you're looking at a rodent coil, you also have a sympathetic inductive frequency there, and so sometimes the frequency you put in, you can measure at different places around the coil, and you actually have a different frequency or harmonic of that frequency.
Just a comment, to go back to your plants for a moment. We had a similar situation where a single crystal was excited, shall we say, with a DC current at 8 hertz or thereabouts. Actually, the Schumann resonance.
Yeah, 8.67.
And we got similar results to what you showed there. That's to say that the treated area appeared to be exponentially growing compared to the other one. So maybe that's just another little
tidbit of thank you.
Piece to the puzzle.
No, I appreciate that. Thank you. What was your name? What was your name, sir?
Most highly honored Steve.
Hi, John Maliski here.
Hey there.
I grew crystals all my life.
Okay.
About 40 years, I made single crystals a day. Hafnium carbide, silicon carbide, sapphire.
So you may know what's going on inside those
so
things.
I wanted to get a little more. What else can you tell me about that crystal battery?
I can't tell you too much because I'm not aware of the insides and what kind of polymers or crystal. You know, all I can tell you is that I've my own experiments with other types of crystal batteries, which I've not played or know the insides of the one that Marcus Reed has. The one that I've played with just have a copper bowl, the magnesium, and the food grade alum powder, and the water. And what I believe happens is there's a piezoelectric effect with the crystals when they start growing. They actually press against each other and kick off electrons that are picked up by the copper and the magnesium, which then go to the cathode and the anode, and that goes to the light and lights it up. That's what I believe is happening.
Okay, I was wondering so that you made yourself, you didn't buy that?
Yeah, you can, right now, I believe they're just coming for sale. Those crystal batteries from Marcus Reed right now.
Who's selling them?
I believe it's, what's the website? It's Charles Frazier, the guy that you saw we've been working with. He doesn't have a shopping cart up yet. If you want to just email me, and I'll get him to you.
Okay, I'll get your email. I'm jbmaliski@aol.com.
Okay, well, I need to talk to you afterwards because I'd love to talk to you about the crystals. So.
Okay, thank you.
All right, thank you.
Thank you, Big John. The most highly honored and esteemed Mr. Allen.
Sterling Allen from PESN. Quick question. I really want to applaud you for basically open sourcing this technology. And do they go to Native Clean Energy to have like a forum and discussion about sharing results, posting videos? Is there something along those lines?
I will put one up when I get back.
Thank you.
Hey, Freed.
Yeah, I'm Freed. I'm part of the VBM crew. And my question is actually a quite short one because it happened today. Like everything in the VBM field, things happen overnight, over day, in seconds, very fast, and we mostly can't hold up with it. So today, Rolland had the encounter with the Bedini motor and a battery, and I would like that you share the information what happened there, even.
Yeah, absolutely, and also still demonstrate this for anybody that wants to come up after this and look. But yeah, what was interesting is we had the Bedini motor hooked up to the coil. The Bedini motor, if you guys are aware, sends it cuts off, and it has this electromagnetic field that it cuts off, and it sends this voltage right into the battery, and it basically helps desulfate batteries, rejuvenate them, and all kinds of cool things. So we had this thought, hey, why don't we see if we can charge the battery faster by hooking up the Bedini output to the input of the vortex coil and taking the output of the vortex coil and putting that into a battery. And by all means, it looked like it charged it quite a bit faster, and we were like, whoa, cool, great, you know. Then we actually had tested the coil after that, and it didn't seem to resonate like normal. And we weren't sure why. What we think happened is that the coil got magnetized, because there's somebody else in here who was explaining that to me.
Rolland, may I interject there?
Yeah.
I tested it. One side of the amplifier has failed.
Oh, it did?
No, your coil is fine.
Okay.
I tested the amplifier. The amplifier is at fault. The coil is perfect.
Okay, well, then there we go.
That's why we put another there's another
So
amplifier
it is
on
that.
top.
So it wasn't the Bedini, so we don't have to worry about connecting them
We
together.
were
Okay.
hunting,
Yeah,
trying to figure
yeah.
out what the challenge was, but the coil is
Awesome.
actually really good.
Awesome. Okay, thank you. So there we go. There's the answer.
I just figured that out just when I was finishing hooking up the
okay.
second channel there for you.
Oh, okay. All right, thanks.
So I'm just curious if you've had any kind of results or anything, side effects from just the shape sitting
field.
there without being plugged into anything.
I haven't physically known anything, felt anything, not yet. So no.
Thank you, Jack.
Instead of using LEDs to receive your power, have you ever tried a resistive load like an incandescent bulb?
We've lit up incandescents. We've got videos.
Do you get equal? You take 28 watts of incandescent power.
Yep. Yeah. There's that on Daniel's channel. You can find that fluorescence, incandescence, LEDs, neons, and halogens. Yeah.
An observation that potentially explains your plant experiment as to why the area closer to the coil had the more lush growth. If that road coil is in fact a lens collecting and distributing and concentrating south monopoles. From Callahan's work, south monopoles are the earthbound monopoles that are stored in the earth. Your soil in that container is shielded in a plastic or some kind of a container. It doesn't have continuity with the earth, so it's depleted. It's going to deplete the south monopoles in the soil faster.
Oh, interesting.
That coil replaces those. The north monopoles are cosmic, and they're available to the plant. So there's a potential explanation for
Callahan's work?
what was observed.
Callahan's work? Is that what you said?
I'm sorry?
You said somebody's work. Callahan's work?
Callahan.
Okay.
Yeah, Phil Callahan.
Phil Callahan? Okay. I'll look
and
into
John
that.
Maluski had the tree in the diagram the other night that showed the diagram. It's true for all plants. It's not just trees.
Wow. Okay.
So
thank you.
Anyway, there's an explanation that could.
That may be some weight to that. Thanks. Yeah.
I'll hold it for you.
I'm terrible with notes,
Here,
with
I can
names,
hold
so
it while you-
I'm using
okay.
the notes. Jeffrey Hayes of the Tesla Motors presentation said he would believe over Unity when he could see things being done with a resistive load. I have a 500 ohm, 100 watt resistor here if you'd like to try it for the output.
You have a what?
A 500 ohm, 100 watt resistor. If you go directly into a resistive load, then the current and the voltage are in phase, and so there's no question of whether
You can hook it up over there if you want.
inductive effects.
Yeah, we'll hook it
It's
up.
here to try.
Yeah, cool.
Okay. I think you've got a few moments. Do you
Yeah.
want to do a practical?
Yeah, let's go have some
Hey,
fun.
sick 'em doggy. I was wondering if there's anybody in the crowd that might know a little bit about a rodent coil more than we do.
If you guys want to come up maybe and look at this, or leave them there?
Yeah, they gather around the screen there and okay. You've got both channels hooked up now. You can actually. You want the signal generator turned toward you?
Sure.
Okay. We'll turn sideways and let's see. We'll go ahead and set the gain here, and you're actually hot.
All right. So.
Okay.
Oh, I see. We need to change
You can step
this.
right up to the plexiglass, but don't step past it. Thank you. I'll step out of the way. We had a quick question there. Dinner is inside. It'll be where the social was, last night. Okay. By the way, Roland, would you like a diametrically polarized spherical magnet there?
Sure, that'd be fun.
I can grab one.
Something has actually changed here, John. Oh, what did he change? Okay, yeah.
Get the magnet case. The case with all the magnets. Bring it.
So something changed here, John.
By the way, for those of you who are noticing we have one, he's our cameraman, so please don't follow him. He also knows what to do around extreme magnetic fields and extreme electronic fields.
Something changed. I think this is at the right hertz.
Okay, you're at what, 4.99 kilohertz, and you're on, and then there's the phase 2, and let's see, let's switch to phase 2 here. Oh, see, there's phase 1, you're on 5 kilohertz, and phase 2 is on 5 also. So you're both.
Is it because
and
the amplitude?
We've got now you're going to heat that thing up real quick there. And see, and we split the main and the monitor so that each one. This is the amp for side 1, and this is the amplifier for side 2. And
what?
Yeah. Let's see. Where is that?
That's weird.
Okay, open it up, please, sir. Okay. Now, there should have been.
Yeah, it's not.
The one that lives in here, that round one. We need to find it. Yeah, and we need that plastic one. Where's that?
So
there it is.
I know why.
There's one of them.
So I think, John, we've got it 2 inputs. We've got it. This is the input. We've got and an input here too. So this should be the input. This should be the output. So this did you put?
You can disconnect that.
Yeah, that's.
Okay.
Okay. There we go. That's why.
Okay.
Okay. We just had a little wrong there. That's fine. So basically, without the resistive load that I know he's itching to put on here, you've got the input voltage right here, which is, I guess we only need, input voltage, about 10 volts going in. You can see that, 10 volts. And then we've got the output voltage, which is 187 volts, which you guys can see. And again, there's no primary and secondary, so we shouldn't be seeing a higher voltage. It just should not happen, but it is. And then in order to show you the amperage going in, we've got about 1.3 amps, let's change the little 1.3 to 1.6 around there. And then I'm going to unhook this and change it to the amp reading. And you can see it's 1.9. 1.7. Sometimes it amplifies the amps, oddly enough.
Once it's stabilized, can you announce what these numbers mean?
Input is over here, and the output is over here. So the input volts, 10 volts in, 1.5 amps in, and we're, oddly enough, showing 2 amps, or 1.8 amps out, and let's see how many volts again. 187.2 volts out. And so we'll also show, if you take this, the reason you get this spiraling magnet thing, at the lower frequencies, it'll spiral and you'll spiral it back up. You can't feel anything there right now.
Here's one that's marked so that.
Oh, interesting.
Yeah, oops.
So yeah, it doesn't have the similar effect as the rodent coil.
Okay. You know what? If we change the frequency, see now, are we?
Just on the first channel.
Okay. Now.
So the resonance stopped because it resonates at a certain, so you'll see that the voltage went way down. He's bringing the frequency down. So it only resonates at certain frequencies, but you'll be able to.
It may support the.
You feel it oscillating?
Yeah, it's just, you know what? It's sitting right over that caster cup. Let's move it to the middle where it's not. Do you feel it oscillating at all?
Nope.
Okay, hold on. Let's see. Tell me if you feel it oscillate.
Nope.
Let's see. Now let me trace out which. That should be channel 1. That's power amp 1, and that should be the sine wave on that.
Yeah.
Okay.
Drop it down to like lower. No.
Yeah. Now, are you starting to get some?
Yeah.
Okay. Now, oh yeah, there it is. Now it's happening. You feel it?
Yeah.
Okay. Now, I don't know if it'll suspend it yet.
No. See, the Rolland coil, which is a little different than this one, would
Yeah.
support it for sure.
Yeah.
But this one is a little bit different than the Rolland coil, so it doesn't have some of the kind of fun things that the Rolland coil does. Nope.
Yeah, this one probably. Yeah, there's effects there, but it's now we can take that back up to
4900.
okay.
Is the second output activated on the generator? I don't see the LED.
Yep.
You want that to 5 kilohertz, correct?
Yeah.
Okay.
Oh yeah. Now where'd you go there? So it's 800 volts out.
Okay, now you're at 5 kilohertz.
So you must have turned the volume up, right? Is that what you did? You turned. Yeah, it's up to 800 out now.
Yeah, there we go.
Down to 500 volts out now. And it's just 11 volts in and 574 volts out. One of the things you'll see with this is the massive inductive field. This is 50, 60, 70, 90 amps, 109, 113 amps in the field right now that this is measuring. It'll probably go 150. And it kind of, you can see all around, you can see the equator there. So there's a big field. You guys are all in the field for sure right now. And so that's why we can get these magnets to spin real hard on there. So let's go back and take this over here and measure this amps again. So 2.7, 2.8 amps going in.
I'd like to know voltage in, voltage out, amps out.
Okay, voltage in, 12 volts, amps in, 2.8 amps.
I can't hear you. Can you announce it louder so I can understand?
Voltage in, 11.64.
That's a volts in.
Volts in. Amps in, 2.55.
Okay.
Volts out, 200. And then amps, 2.03. 2.04. It's at 5 kilohertz.
Repeat again, volts out is what value?
What's that?
210?
2.04 amps.
2.04.
So there's a little less, at the moment, there's a little less amps, like half of an amp less.
So less volts coming out.
No, there's 200 volts coming out at 2 amps.
Okay. Wow.
12 volts going in at 2.4 amps. So that's the difference there.
16 times or so.
Yeah. I'm aware of that. That's why we had an O-scope to measure the wavelength.
What are amps coming out?
Amps were 2 amps.
2 amps coming out.
Right.
10 amps going in.
2.4 amps going in.
Wow.
Well, there you go. You got a rodent coil there. You got a second channel you're putting into that one?
Yeah. That coil should have jumped.
voltage times the peak voltage times peak current times power factor. Power factor is the phase angle between it. It can be anywhere from 0 to 1. Oh, see, yeah. That's basically, if you're going into a resistor, the energy goes away. If you're going into an inductor, the energy comes back. And there's no loss.
I'm encouraged.
Is Marco here?
This cable is not active.
Marcus here.
Oh, there he is.
I have been wanting to ask this question for years.
See, there was another cable laying back here.
Do you want to put your what you got here?
Got a plug for you. It's 510 ohms. It's good for 100 watts. So if you go at, if you're
So what's supposed to
200
happen here when I plug it in?
What?
What's supposed to? There's
Well,
there's
it's just
no.
it's a resistor
Gotcha.
across the line.
Oh, okay. So just plug in here and here.
Yeah.
Okay.
And that's 500 ohms, and this is another 10 in series.
Okay.
So that if you want to measure the current by measuring voltage, you can do it there. But the current and voltage have to stay in phase with the load, so you know that the peak voltage and the peak current actually can be multiplied to get power.
Okay. So basically, I'll hook it up to this right here. Right here.
Okay.
Oh, he's not.
Be careful, it could be very hot. Where's that one with all the colors on it?
Oh yeah. Right.
He said, oh, I'm gonna trade you.
Does he even have it on? So yeah, it's basically what happens is nothing comes out. So there's no resonance anymore. It's 0 volts, 0 amps, nothing.
Okay.
So that's what happens when you put this thing on it.
Kills it. Put a resistant load on it, it kills it.
So that may not be able to resonate with the circuit like how the rest of the resonation is.
Basically,
Yeah.
if you're putting a damping resistance across what
A resonant
you have
load.
in circuit.
Right.
But for people who ask the question, do you really get more power out than you put in? You have to answer that with a resistive load.
Oh, really? So looking at the
That's what
wavelengths,
they're looking for.
looking at the wavelengths doesn't matter. The amplitude of the wavelength in and out doesn't matter?
You send it into some load, and the whole circuit is reactive.
Mm-hmm.
The current is 90 degrees out of phase with the voltage, and there's no power.
So when all the lights light up, that's just a
It would not
unique...
light up a light. It would light up an LED because it's a nonlinear device. It would not light up an incandescent light.
We've lit up incandescent lights, we've lit up fluorescent lights, you know.
That is
They're-
proof. But now you have to get the voltage and the current across them to see the power.
Huh. Okay, well yeah, that's further research we need to do to figure that out, yeah.
I'll send you an email and we'll talk about it some more.
For sure, yeah, and yeah, absolutely, thank you, yeah.
Look, I'd love it to work.
Yeah, oh, I'm sure we all would. Oh, I see.
Yeah, it's getting ready to
It's getting ready to dance.
dance, yeah. Just gotta get the frequency correct here.
Oh, I see. And if anybody wants to smell some ozone, we can turn the frequency or amplitude up on this and we can make some ozone. Maybe it's the attraction to the metal on the table.
Yeah, you know what? The fact we're on a metal tabletop is probably
It's probably pulling it down. Yeah. Looks like it's losing some gravity there.
Side to this side, we can get this on camera.
Oh.
Step up to this side.
This
right
side?
Here and just look from here.
Ah, okay.
Watch him from there.
Ah, okay.
You know what? I don't know why that's not. Now this one right here is the.
Yours. And this one is the other one?
I have to admit I'm not perplexed to why that.
Really?
Well, that's not.
See if you can smell anything coming out of that coil. Come here. See if you can smell anything coming out of that coil. Go put your nose over it. Yeah.
What am I supposed to sense?
Oh, it's not. It's not. I guess it's not resonating that high. That's, I'll be careful with your hands. Usually it would.
Do you think we have a demonstration of overuse
I do because of some other stuff that he told me about, some input and output that they did, and the tests that they did to rule out certain things. And I recorded him earlier today talking about it. So yeah, I do. Cool.
So you've got
20
volts coming in.
26, 20, 23.
3 going in. And how much coming out?
23, 5 amps, 400, and then 5 amps out.
5 amps going in, 5 amps coming out, but the voltage is going up.
Right, right.
From
26 to
What was the voltage?
412, 13.
And the amperage was
5 in, 5 out.
stayed about the same. But got a huge increase in voltage.
Right. That's the, whatever's going on in there is doing that.
Wow.
It might.
See, I've never wound one of these ones.
I'm just playing way low on the scale here, but I'm a little bit perplexed why that isn't dancing.
Would it dance on the floor?
You know, it usually dances right up there.
Ah.
I'm trying to figure out why it's not. See, I'm gonna try using the other.
Channel?
Yeah, the other channel.
Okay, yeah.
And you don't have to do that. I'm just gonna change it right here.
Oh, I see.